Let hx equals negative 5 over x. Select the correct description of the one-sided limits of h at x equals to 0. Okay, one-sided limits of h at x equals to 0. So what happens when x approaches to 0? So this kind of graph, basically 1 upon x has a shape of like this. When you multiply it with negative, what happens? It gets mirrored in this axis, so the graph looks like this. And basically multiplying with 5 just makes it more, more steeper, so the gradient or the slope increases and it becomes, more like this. So that doesn't matter that much when we are trying to find the limit. So as you can see, what happens when x tends to 0 from the positive side? So from this side, as you can see, it approaches negative infinity. So which means a and b is crossed out. And from the left side, or approaches 0 from minus. So this is positive infinity, as you can see. This is the positive y-axis. So that means C matches what we have found here. So C is our answer. And there we go. So next question. Let hx equals this thing where x is not equals to negative 3. H is a continuous for all x is greater than negative 12. So we have 0, we have negative 12, and this is the interval for which h is continuous. And we have to find h negative 3. But the problem is when you insert negative 3 here, negative 3 plus 3 equals 0. And if you insert negative 3 here, negative 3 positive 12 is positive 9. Positive 9 is 3. 3 negative 3 is also 0. So you have 0 divided by 0, indeterminate form or indeterminable form. We can't determine from this form, so we have to change it using using conjugates. So we multiply it with, so this equation, we multiply it with the conjugate of this. So we have x plus 12 positive 3, and because we have to preserve equivalence, we divide it with the same thing in order for it to cancel out. Now what we can do is we can use the formula a plus b times a minus b to be a squared minus b squared. So this thing, when we square this, the square root disappears. So x plus 12 a squared minus b squared, which is 3 squared. And 3 squared is just 9, divided by x plus 3, and this plus 3 becomes x plus 6, and this thing is multiplied. Oh, sorry, this thing is being multiplied, so we can't actually do this. So we have x plus 3, and on the numerator, what do we have? We have also x plus 3, because 12 minus 9 is x plus 3. Now this x plus 3 gets cancelled out with this x plus 3. So above we only have 1, and on the denominator we have x plus 12 plus 3. Now we can try and find, insert minus 3 here. So 1 upon root minus 3 plus 12 is 9 plus 3. So we have 1 upon 3 plus 3, or 1 upon 6. There we go. Okay, next question. We want to find the limit of this equation as x tends to 0. Direct substitution or other algebraic method don't seem to work. Look at the graph of fx equals to x by sin x. We can estimate that the limit is equal to 1. Here we go. Okay. To prove that limit of this function as x tends to 0 is 1, we use this Squeeze theorem. Brenda suggested that we use the function gx equals to sin x, and hx equals to sec x in order to apply the squeeze theorem. Does Benda's suggestion seem to be correct? No, it's not. Why? Because Benda's suggestion is incorrect because it's not true that one function is always below f and one function is always above it for all values near x and near 0. This is true. As you can see, this function h has the values, all values above this function, and so is g. This is true, but this is not the issue. It's not our answer. Brenda's suggestion is incorrect because it's not true that the limit of g and h are both equal to 1. This is true. The limit of g as x tends to 0 is 1. But what about this? This is at x tends to 0, the limit is 0. So we have limit of 1 and we have limit of 0. Both limits must be the same. So this is actually the issue. Alright. The function h is defined over the real numbers. This table gives a few values of h. What is a reasonable estimate for a function hx? The limit of function hx as x tends to 4. Well, as you can see, as it is getting closer and closer to 4 from both sides, we are getting different value. Here we can say something like 5, or here we are saying something 0, maybe negative 0. So the limit from the positive side, as x tends to 4 from the negative side is equals to, let's say, 0, but as x tends to 4 from the positive side is 5. So these two limits are not the same. Hence, the limit doesn't exist, because for the limit to exist, both the limit from the positive side and the negative side must be equal, which is not in this case. So we say it doesn't exist.